second, please get out something to take some notes on, and then we will go ahead and jump into this in just a little bit. So hopefully you guys...
What notes should I write?
Don't write this first page, Lucas. I'll tell you when to write, okay? Okay. So systems of equations are basically just two or more linear equations together. Now, this kind of might sound really useless if you're just thinking like, okay, well, y equals 2x plus 3 and y equals negative 5x. Like, that doesn't seem like it has any good real world applications just yet. So I'm going to show you where we can use it in a real life situation. So we've got 3 students running in a race. Who should I pick on for this? Who's really fast? Anybody?
Me.
Okay, Brennan, you're our fast runner. Who's kind of fast? All right, Pamela, you're our second runner. And who's really slow?
Me.
All right, Todd, you're our third runner. So Brennan, Pamela, and Todd are all running a race. Brennan's going to be our fastest runner. He runs 10 miles an hour, and he's going to start at the beginning of this race. We're giving Pamela a little bit of a head start. She's a little bit slower than Brennan, but she's still pretty fast. So she's running 8 miles an hour, and we start her 4 miles up the track. And then our slowest runner, Mr. Todd, he only runs at 5 miles an hour, so we're giving him a 12-mile head start.
Yeah, I basically just walk. That's it.
Yeah, that is actually kind of just a fast walk, but that's not really the point. So our question is, when are our fast runners going to pass our slower runners? And then the other question we can ask is, who wins if the track is 25 miles long? Who wins if it's 31 miles? Don't ask me why they're running such a long race. That's ridiculous, but I wanted to use miles because it gives us smaller numbers. If I was doing feet and stuff, then it'd be conversion, and that's really annoying. So to answer our previous questions, we first need to write equations for each of our runners. We still don't need to write any of this down. This is just an example problem, so I'm just going through it step by step. But our first runner, Brennan, runs at 10 miles an hour. So his slope is 10. He's running 10 miles per hour. His change in distance per hour is 10. He starts at 0 miles. So his y-intercept in this case is 0. So Brennan's equation is going to be y equals 10x. We could have a plus 0, but we don't really need that. So we just y equals 10x. Pamela, on the other hand, she's running 8 miles an hour. So we've got y equals 8x. And then she starts at 4. So wherever she is, she's going to get an extra 4 miles ahead of Brennan. So we've got plus 4. And then for Todd, running at 5 miles an hour. Oh, whoops. Here it says he starts at 15. Oh, this should have been changed to 15. Sorry, guys. Ignore me. You get a really big head start, Todd. So Todd goes 5 miles an hour. So he has a slope of 5, 5x plus 15. So now we graph these equations and see where the runners are going to pass each other. So here I have a graph. I'm going to graph each of my different lines that are all written up there in fancy colors. So I'm going to go ahead and use similar colors. So if we do y equals 10x, I'm going to get a point at 0, 0. If I plug in 0 for x, we're going to do 0. If we plug in 0, we're going to get 0 again. And then let's try maybe 2. So if we plug in 2 for x, we'll get y equals 10 times 2, just 20. So we have 0, 0, and 2, 20. So 0, 0, 2, 20. So Todd's line, or Brennan's line, looks something like this. Then we've got Pamela's line. So Pamela running y equals 8x plus 4. We'll start with 0 again. Oh, I'm getting some. Thank you, Jocelyn. I appreciate it. I think it's a pretty beautiful line, if I do say so myself. I'll go ahead and use 2 again, just so that we can stay consistent. So if we plug in 0 for x, we have y equals 8 times 0 plus 4. I'm going through the graphing of the lines a little bit quicker since we've had some practice with that at this point. So y equals 0 plus 4, which is just 4. Then if we plug in 2, equals 8 times 2 plus 4. 16 plus 4, which equals 20. What's that, Todd? So this line, oh, this is going to be so hard. Todd, your audio is cutting out really bad. I can't hear anything you're saying. Sorry, dude. You want to type it in chat, Todd? So then Todd's line, y equals 5x plus 15. Again, if we use 0, plug in 0 here, we'll have 5 times 0 plus 15. It's 15. So first point's right here. And then we'll use 2 again. So if we plug in 2, we have 2 times 5, which is 10, plus 15, 25. So we have 2, comma, 25. So Todd's line looks something like this. Right there. Now, obviously, these lines are awful. I know I suck at drawing lines. They're all curvy and not in the right spot. It goes against the Achilles paradox. Is that like your heel's gonna break? So as we can see, we have a couple of different solutions. We've got a solution to this right here. This is where Todd, you're still cutting out like crazy. I don't know what's going on with your internet, man. So this is where Brennan is going to pass Pamela right at the 2-hour mark at about 20 miles. And then Brennan is going to pass Todd, it looks like, at about the 3-hour mark at about 30 miles. So that one would be right here. This one's a little bit harder for us to determine. We're going to worry about this one actually tomorrow. We're not going to do that one today. But as you can see, we've got these 2 points, so we can figure these out. Now, we can also answer our initial questions. So we asked, when will the runners pass each other? We just circle all the points for those. We could calculate them out more specifically if we wanted to. But we could also ask who wins if the race is 25 miles. So what we do is we look at 25. We see who gets there first. And in this case, that's Todd. He had a big enough head start that even though he was going slower than the other two, he managed to get there first. This line is absolutely awful. I don't even know what's going on there. But Todd would have won if it was to 25 miles. If it was 31 miles, though, so that one's up here, right above this line, it looks like it's pretty close between Todd and Brennan, but since they pass right about here, it looks like Brennan's going to have him beat by just a little bit. So Brennan would win if it was 31 miles. Sorry, Pamela. It looks like you didn't have a big enough head start. So Brennan would have already lapped him. Not quite Brennan, but so hopefully you guys get at least the idea that this is something that can be a little bit more useful in real life. So now on this next page, this is where you guys want to start actually writing some notes down. So this is the steps to solving a system of equations. Doing this by graphing really only has 3 steps. The first step is to plot your first line on the graph. Now, obviously, we know that plotting a line has more steps than just plotting it. You're going to have to actually solve for points and draw the lines and stuff, but you already have notes on how to do that. The second step is to plot your second line on the same graph. So if you have one chart that looks like this, and you're going to plot your first line, plot your second line on the same graph. And then step 3 is just determine the point at which the 2 lines intersect. Your answer is always going to be in the form of a point. So it's going to be something x comma y, always going to be in parentheses. So you can have an answer like 2 comma 4, negative 3 comma 6. But this is always going to be the answer to a system of equations. And that's whether we solve it by graphing or substitution or anything else. So make sure you have these steps written down. I know they're fairly simple in terms of what they actually say, but this is going to be an important thing to do. So really, if you can plot a line on a graph, you can solve a system of equations by graphing. So this plotting the line thing that we've been talking about for 3 weeks now, this is really, really important. This is a really important skill for math, for science, for just about everything. Unless you're going to be a writer, then you won't use it very much. I won't lie to you there, but you guys get the point. Check and make sure my attendance is fixed. Also, I should probably mention to everybody that for notes, if after the first test and stuff, or after the second test, whatever, if we get to a point where I feel like people aren't taking notes enough, I'll start requiring them and checking in on them. But rude, Todd. So please make sure you're writing this stuff down. I know it's not particularly fun, but it is really important, and I can't see what you're doing, so I don't know if you're doing it or not. So will 1 minute be enough to get this finished up? It probably is true, Riley. No, more than a minute? Okay, I'll give you a little bit more than a minute. There, Todd, are those curved enough parentheses for you? And is that a straight enough line for you?
Made you self-conscious.
Hey, I'm only self-conscious some of the time. That's actually probably the straightest line I've drawn in this whole class, to be honest. There we go. Favorite. I mean, yes, Todd, I probably could. Okay, does anybody need more time? I'm not your bro, pal.
Oh no, not this again.
Okay, I'm gonna move on. So this is one practice problem.
Wait, go back for like 2 seconds. Let me just take a picture of it and then I'll take the note.
Okay.
Just for 2 seconds.
Wait, what have you been doing for the past minute and a half then?
I've been doing it. I've been writing.
Oh, okay.
I'm a very slow writer. I'm sorry. Just
no worries. Just checking. Just wanted to see.
okay, I'm done.
Okay. So what we want to do is a little bit of practice before I let you guys loose to work on some homework, is determine the solution to the following system of equations graphically. So what I want you guys to do, since obviously I can't actually make you draw the lines, unfortunately, because then we could make fun of your lines instead of mine. What I want you guys to do is give me 2 points for each of these lines. We'll call this line A and this line B. Then I will graph them based on the points you guys give me, and then you can tell me what answers you get. Brennan, no. Also, it's not as funny as I think you think it is. You know, I have to like go out of my way to avoid using examples that give me an answer of 69 just in case Brennan is there. Uh, 1 and 2 does not work either. Those aren't even points. As you guys work on this, I'm just going to mention really quick, your homework for today, you again have the option to do an IXL or math space assignment. Let's see, the math space assignment, I believe, is a short custom one, but let me double check. Oh, no, it's not. Never mind. It's a normal. Yeah, it's a normal math space. But a lot of you guys have a little bit of progress on it already from previous assignments. So it won't be as long. The IXL though is going to be AA.3. So IXL AA3. This is on the Google Classroom as well. But yeah, you have those two options. And then the rest of the class today is going to be a work time. So those of you that are having issues with some of the other stuff, please stick around and get some help. If you're having trouble with this part, if I ask you to graph this and you're not sure if you can do it at this point, then you definitely want to stick around and get some help with that because we're going to be using this for the entire rest of the term. Jennifer, good on both. Good job. Todd, those work. Dane, what is your X? Okay, that's good. Yep, Todd, good. Let's see, Elsie showed up. Todd, I need to make sure you can solve the actual graphing part too, but you can start in on the homework if you want to. Just make sure you stay here till after I graph them. So let's see, I've gotten like 4 people now. Hopefully everybody else is working on this. Yep, that works for B, Dane. But Dane, you need 2 points for each one. That's good, Asa. Just when you get your points, let me know. But thank you for checking and telling me. No worries. Take your time. Good, Pamela. Those both work. Good, Dane. Those both work. First point is good, Pamela. Check your second one. There you go. Good, Dane. Okay, I'm gonna give another minute on the first one. Then I'm gonna start talking about it. That part I don't think so, Pamela. I also don't know how you got that, considering. I don't know that part yet, but okay. So the points that a lot of people are coming up with were 0 and 6, which is a great choice, or 0, -6, sorry. 1, -3, also a good choice, and 2, 0. These were the 3 most common ones that I saw. Solving for these, if we plug in 0 for x, we'd have y equals 3 times 0 minus 6 equals 0 minus 6, which equals -6. So that's how we get the first one. If we plug in 1, we'd have 3 minus 6, which gives us -3. We plug in 2, we'd have 3 times 2, which is 6, minus 6, which is 0. So if we plot these, we have 0, -6, that's right here. We have 1, -3, that's right here. We have 2, 0, that's right here. So I'm going to give myself an extra point to start with. So the first line looks something like that. Actually, I might need to make it longer. Let's go ahead and extend it a little bit. Okay. Then the second line, let's see. Some of the points that I saw were 0, 9, 1, 7, 2, 5. You could have gone further with them. You could have done 3, 3, and then probably could have found more too. So if we graph 0, 9, that's right here. 1, 7 is right here. 2, 5 is right here. 3, 3 is right here. Actually, I should graph this in a different color, huh? Just a second. Okay. So this one looks something like this. And the intersection is right here. In this case, again, because I'm drawing the lines by hand, it doesn't necessarily look like it's exactly on this point, but we can see that it's approximately at 3 and 3. So our intersection here is 3, 3, like that. Now, one of the things we can do to check our answer when we're doing graphical method is to plug in this point into both of the equations and make sure it gives us the right answer. So if we plug in 3 for x into the first one, we're going to get y equals 3 times 3 minus 6. 3 times 3 is 9, minus 6 equals 3. So that one works. And then if we try it with the second one, y equals -2 times 3 plus 9. -2 times 3 is -6 plus 9 equals 3. So this one works as well. So that's just a way we can double check our answer. So again, if you're having trouble with the graphing, please stick around, get some help. It's really important that you get this down. So if it's something that you're struggling with, please stay. But otherwise, you guys are good to go. The rest of the day is a chance to work on stuff. And again, if you're falling behind, please